Okay, we'll get started. Good morning. But you can do better than that. Good morning. Yay. Not bad. I'm Mark Freidenberg from Bentley University in Waltham, Massachusetts. And the topic for this session is a new topic that I haven't presented at Cengage before, so you guys are in for a treat or an adventure. So fasten your seatbelts because this is going to be a bumpy ride. We're going to look at the world of big data and what that means and how we might incorporate some tools for using big data in the classes that we teach. So the topic, I should learn to stand away from the slide deck. So the presentation is called Drinking from the Fire Hose, Tools for Interpreting and Teaching with Big Data. Why is it called Drinking from the Fire Hose? Because the idea behind the data on the web today is that it's flowing at us at rates so fast you would never, that we need to figure out how to deal with that. So what I'd like to do today is introduce some of the concepts around big data and show some examples of how you might introduce it in a class you're teaching as well. So I come from Bentley University, which is just west of Boston. I teach our Introduction to IT course there and another course called Web Trends and Web Technologies and Trends. Bentley is a 4-year business school, and that's sort of what our campus looks like. So if you come to visit, you'll feel at home. In my world at Cengage, I've written an update to the Web 2.0 book, which I published a couple years ago, which actually has a whole section on open linked and big data in the last chapter. That's available as a CourseMate, and I've joined the authoring team for Discovering Computers this year. And so if you look at the exercises on web and mobile devices and tablets and cell phones and social media and all that sort of stuff, I probably wrote those. And a whole bunch of other things in there as well. So check out both of those in the Learning Annex, and now we can get down to business. We'll start with him. What? Kevin. Why Kevin? What? Good dancer. What else about Kevin? 6 degrees of separation. How many movies and TV shows has he been in? What? A lot. Like 77. So I want to start off with a story about Kevin Bacon. There is a website that asks a very important question. What's your Bacon index? So here's Kevin Bacon. Suppose Bob was in a movie with Kevin Bacon, then that would give Bob a Bacon index of 1. If Ann was in a movie with Bob, then her Bacon index would be 2. If Joe was in a movie with Ann, then Joe's index would be 3. But if Kim is in a movie with Joe, then her Bacon index is 4. But if Kim all of a sudden does a movie with Bob, then her index drops down to 2, right? So this is a hard problem to calculate. And for some strange reason, people actually worry about this sort of stuff. There's an entire website called the Oracle of Bacon, where you can go, and let's see if I brought it up here. This is oracleofbacon.org. Somebody give me the name of an actor or an actress. Let's see if I can type it correctly. And we'll take Julia Roberts the first. And so she has a Bacon index of 1. Somebody want to try somebody else who might have a Bacon index of higher than 1? What? So we'll take Phyllis Diller the first. And so she has a Bacon number of 2. So how does this whole thing work, and what does this have to do with big data? Well, let's close that one. There's a website called IMDb, which is the Internet Movie Database, that lists information about actors in every movie that ever existed. That website has an API, which is an application programming interface, which allows developers to access this huge database. And so you can do things like this. Let's see. Let's see if we can do this. IMDb Q equals, and give me the name of a movie. Les Mis. And what it does is it gives me back data from the database. So I used a web call, I called the service on the web, and you can see this is giving me data formatted in a format called JSON for JavaScript object notation, which is a format that data is represented for sharing applications on the web. It's sort of like XML. You can represent the same information in an XML format as well. This is slightly more compact and easier for applications to be built using. And so this huge database has a way for developers to grab information out of it. And what do you do with it? Well, you build applications. So for example, I can go to Google, and I can type in, somebody give me another actor?
John Travolta.
Why? So if I type in John Travolta and I type in bacon number, Google will automatically tell me that it's 2, because they used the API from IMDb in order to do this calculation. Then when you're searching for it, they'll tell you exactly what you want to know and how you got it. Same way as Oracle of Bacon works. Whoops, we'll go there later. And Adam Sandler's bacon number is also 2. And it turns out that you've heard the phrase 6 degrees of separation. There's like only 1 or 2 people who have a bacon number higher than 6. Most people are 2 or 3 or 1. And how does this work? So it works because of IMDb has this database. And one of the things that they try to relate is who knows whom. And the technology that uses is called friend of a friend. The logo for friend of a friend are those 4 buttonholes in the corner. And basically the way it works is they've indexed this database in such a way that they say who you are and then a list of who you know. And so person A might know person B, and person B might know persons C and D, and you get this social graph. This is the same technology that Facebook uses to index your friends. So you have a Facebook social graph. We don't really care. Maybe we don't care who are 6 degrees of separation from Kevin Bacon, but maybe we do care about this. Here's LinkedIn Maps. Let me log in with my LinkedIn password, and I am not a robot. And what LinkedIn Labs is doing is it's going through all of the relations I've got in my LinkedIn account. There's my brother. I don't know who David Lamort is, and some folks from where I work, and other people I've met along the way. And in a matter of minutes, LinkedIn Labs is going to go through all of my connections and show me my social graph. So while it might be important to know, not necessarily be as important to us to know that Phyllis Diller has a bacon index of 2, if I'm looking for a job, and I'm over here in the middle, it might be nice to know that I'm actually only 1 degree separated from Nancy Gallant. Or let's see if we can find some of my Cengage friends. Where are they? Nope. So here's a bunch of folks who work at Bentley. There's Corinne. And I can see my connection with her and the people that we share. And so this social graph is nothing more than, and I can zoom in on this and sort of see how it's kind of interesting that here's me in the middle, and then you got all these blue people, most of whom are folks at Bentley University where I work, and then you get this orange, these other networks down at the bottom here. Oh, come on.
You mean it's not Republicans and Democrats?
No, it's not Republican and Democrats. Like most of these guys down here are students of mine, and because they've come and gone in different eras, they're different colors. And then you've got people who other friends of mine over here. And then you've got, I don't know, so different circles of friends of mine over here, and then some people who I happen to know because they went to Bentley and are friends of mine. And so you get this relationship of your social graph. And I've got about 600 people connected on my LinkedIn graph, and it took, what, half a minute to index this? Big data, lots of stuff there. So this is a website called InMaps, LinkedInLabs.com, and it's LinkedIn Maps. And it's a way to get, once you get your students on LinkedIn, to show them the value of a social network and the value of a social graph, because if you're looking for a job someplace, you can sort of find people who might be working in the companies where they might want to seek employment. And again, so based on this whole technology of a friend of a friend and how people actually know each other. The data deluge, and how to handle it. When we think of big data, we're thinking of information that's coming from a number of different places, and how can we interact with it, and how can we make sense of it? Big data refers to tools, techniques, and technologies that make it easy to work with data at any scale. We live in a time now where data is coming from so many different places and in so many different formats. Let me show you a short video, and let's hope this works, and then we'll take a look at what some of those data formats look like. Play.
If you were to stand at a road and the cars are whipping by, and all you can do is take a snapshot of the way the road looked 5 minutes ago, how would you know when to cross the road? 9 out of 10 organizations still make decisions this way every day, using out-of-date information. The organizations that are most competitive are going to be the ones that can make sense of what they learn as fast as they learn it. That's what I'm working on. I'm an IBMer. Let's build a smarter planet.
So how can we get the most up-to-date information and make use of it as we go every day? 3 V words to describe big data: volume, velocity, and variety. Volume, velocity, and variety. Big data is data that exceeds the processing capacity of traditional databases, relational databases in particular. The data is too big, or it moves too fast, or it doesn't fit the strictures of database architectures. To gain value from this data, you must choose alternative ways to process it. Let me share with you some examples of database technologies and these ideas. Volume. Data is larger than the conventional relational database infrastructures can handle. We're talking millions of rows of data. Velocity. The rate at which data is generated and processed in real time continues to grow. And variety. Data formats are unstructured and inconsistent. It's not necessarily rows and columns and records anymore. It might be pictures, it might be tweets, it might be videos up on YouTube. How big is big data? We have a new vocabulary all of a sudden to describe information on the web and information as it becomes available. Bits and bytes, those are things we fit in our pockets. Terabyte, but now we're also up to terabytes you might buy at a store. But even a terabyte drive isn't big enough for some kinds of information. Twitter is hitting 50 million tweets a day. And we have a new set of vocabulary, words like exabyte and petabyte and zettabyte and yottabyte, describing how much information is around. 1 terabyte will fit 200,000 photos or MP3 songs on a hard drive. A petabyte is 16 storage pods in a data center. An exabyte is 2,000 file cabinets in a 4-story data center that takes up a city block. Zettabyte is 1,000 data centers, or about 20% of Manhattan. And a yottabyte is the state of Delaware and Rhode Island with 1 million data centers. So these are the kinds of terminologies that people are using to describe the amount of data in the world today. And to put this in perspective, Walmart collects 2.5 petabytes of data every hour from customer transactions, which is a lot. So velocity, drinking from the fire hose. Twitter hits 400 million tweets a day. Customers might analyze call centers at 5 million in a day. There's a lot, big data, and it comes from many different places. Documents, tweets, videos, sensors. The government has data sources out there. You can't see that, but it's recommendations, thumbs up, thumbs down, likes, or recommendations on websites. Wikipedia has been set up in there's a website called DBpedia, which is a structured version of Wikipedia for analyzing its data. And also things like Google. When you do Google searches, right? How does Google know what to put up there when you type in FLU? Because they go based on every time you search. They save your search patterns so they can come up with the most popular terms to guess what you might be looking for, to do that predictive look ahead that we've come to use so much in Google. Every search is saved so that they can guess the most common terminology letter by letter that people might be looking for. So all these are sources of big data, and there's many more. The classic article about big data was published 2 years ago by McKinsey Quarterly, or by McKinsey Company. If you Google McKinsey Big Data, you'll find it. It was called Big Data, the Next Frontier for Innovation, Competition, and Productivity. And the whole point of it was to say that companies make money off of big data, that companies rely on their data as one of their most valuable assets. And we need new ways to process it and people with the skills to analyze it and understand it. Twitter, you may have heard, is archiving every tweet with the Library of Congress now. Huge, huge thing. This was a tweet that came up, that was up a bit ago. Because the Library of Congress is archiving every tweet at Twitter, there's going to be a huge database. And how will it be available? How will it be searchable? And who can access it? Twitter gets 3,000 tweets a second. The data is disorganized. And the way they use it is by making recommendations to you based on the things you tweet about or who you follow, to recommend who you might follow. There's also trends on Twitter, again, based on hashtags. One of the things that's actually kind of cool to do with Twitter, if I can find it, is not there. Is visualize it. So let's see what people have been saying about this conference. Here's a website called neoformix.com/spot, and it searches the Twitter stream of tweets that people are saying about a particular topic. I typed in CTConf13, which is the hashtag for this conference, and it goes through and it tells me in this cute little visualization. I can see who some of our top tweeters are. I've tweeted 4 times today. Course Tech is stacking the deck. Are any of you in this room? Anybody up here tweeting? I can also see some of the most popular words in a word cloud that people are saying. I can see a timeline of when people have been tweeting. So lots of tweets during the morning session earlier this morning. And I can also look at what some of these tweets actually are and see what people are saying. So this is a way this is an application, again, built on Twitter's API that grabs information from the Twitter data stream, from the Twitter, as people tweet, searches for the CT Conference 13 hashtag, and then brings up information as it comes in, almost as instantly as it comes in. And we actually put this up on we have a big monitor in one of the labs in our university, and sometimes we'll just put this up with a current topic as a hashtag and see what people are saying on it, just as an interesting animation or visualization. And then you can sort of click on people and see what they're saying. So it's a cool Twitter visualization of big data to give you a sense of the volume of things that are out there. We're at a time now where we need to create a new hammer. And we need to actually create the world's biggest hammer. Because the tools that we've got to analyze data right now aren't big enough and aren't good enough to support the amount of information that's being generated through online sources such as Twitter, as well as sensors that report temperatures or earthquakes or RFID tags or anything, or all this kind of data that's around today. So we need to create a new kind of hammer. And I'll just mention the names of the technologies that are out there that are associated with big data. One is called Hadoop. It was a project that went open source by Yahoo, and it's a storage technology that allows for storing information in multiple places and in ways that's scalable, because you need to store information as it grows so quickly in ways that the storage can accommodate the growth of the data as well. And also, your relational access database may not cut it when you're trying to search through 1 million records. And so there are new technologies. One is called NoSQL, which is a database structure or a database environment that allows for distributed querying of data in ways that are slightly different from what a relational database model might look like. So what does this mean? Today you change your website today, and Google will notice that change within minutes. 10 years ago, you changed your website, and you had to go back to Yahoo or Google and do a search and do a manual update and say, please re-index my web page, and it might take them an hour or a day before they would do it. So this is how far we've come with this world of big data. All you need is lots of servers, and Google's got them. Amazon is not only a provider of books and goods. Amazon is also a provider of an infrastructure, a technology infrastructure that supports big data. So companies that want to get online might register with Amazon and use their technologies so that all they have to do is create the applications and let Amazon worry about how do I scale this? What happens when I grow from 50 users in a day to 500 users a day or 5,000 users in a day? Amazon's web technologies and big data technologies called Amazon Web Services and Amazon's Elastic Cloud handle those sort of scalability capabilities. What else do we know about Amazon? I bought this camera a few weeks ago. And what did it tell me? People who buy this camera also bought the tripod and the batteries and all the other good stuff that goes with it, right? How do they get this information? Every time they sell something on Amazon, they log not only what you buy, but what else you buy with it, and they create this relationship between cameras and batteries. Makes sense, right? And what do they do with that? They use a process called collaborative filtering so that the next person who buys a camera will say, hey, Bill is looking for a camera. Let's tell him to buy a battery to go with it. Well, what happens if I do this? Suppose I buy a camera, and in the same order, I buy a copy of Black Beauty. Well, is Amazon going to know that people who buy cameras also buy books about horses? What? If they look for a pattern. And so it might be the case that there I am in Boston, and here you are in the West Coast, and I buy Black Beauty and a camera, you buy a camera, and so Amazon's recommendation engine has to know, well, do I recommend that this person buy a tripod or a book about horses? And so this is part of looking at these trends to know that just because I bought a book about horses, that doesn't mean that you should buy a book about horses every time you buy a camera. That's this whole idea of collaborative filtering, using everybody's purchasing patterns to determine what recommendations make sense to arrange for people. And they got it right because their sales keep on going up. Anybody recognize this guy? Say again? Tim Berners-Lee, famous for inventing the internet along with Al Gore. Maybe not. But what Tim Berners-Lee also did was he came up with this idea called the Semantic Web. He said we're going to live in a world where data is going to be related to each other. And let me show you that. Here's an application called RelFinder, which is a relationship finder. And what it does is it links data from many different online sources, such as IMDb, the movie database, DBpedia, which is the Wikipedia database, and a number of other sets. And so let's try something interesting and see if this works. What we're going to do, and it uses a structure called RDF, which is a relational data format, to represent information that, come on, there it goes, to find relationships between things that may not be related. Let's see if this comes up. Please. Not coming. Give it one more time. Let's see. So in my example, and we'll see if this comes out. This is the Julia Child approach here. What I do is I typed in the names of two different musicians, and it found the relationships between them. And let's see if this is back yet. Oh, there it is. Okay. So somebody give me two names of people that may or may not be related somehow. Okay, Julie Andrews. Barack Obama. Let's see what sort of relations they've had. And they have. It's not finding her. Let's try one more time. Let's see if it finds her. Let's put somebody else in here. Let's try that one. Not sure why that's not doing it. Let's take one out of the oven and see. Let's see if one of theirs will work. So, just to give you a sense of what this actually might do, it's searching for relations between Albert Einstein and Kurt Gödel, and skip that. I don't know why this is not coming up. It's searching. We'll come back to it and see if it comes back in a minute. Where'd it go? Still going? Not working today. Okay. Sorry about that. Try that one on your own. Data is also coming through in ways that are unstructured than ever. Facial recognition is big these days. Facebook does it. I went to a page on Facebook and I put my mouse over my face and it knew it was me. It was new and it was a person. And so I could then tag that face and I could know it would know who I am. Big data is in healthcare. Think of a scale that every time you step on it sends data to the web. Or an app on your phone that checks your blood pressure. Or your heart rate. Big data is also available through the government. So here's a website called data.worldbank.org. And here there are tons of different data sets on a variety of topics. And you can actually download these. I'll go back a page. And all these different data indicators on climate change, economic policy, land use, whatever. And so I'm going to choose one. Here I've got one on agriculture. What I can do is take this data, download it into Excel, and then analyze it. Give your students real data with more than 5 rows that they might actually have to make a spreadsheet with. So I brought this into Excel, and the data is actually here in sheet 1. Let me edit it, and this data happens to be in compatibility mode, so I need to click on that to make it real. And so now I've got data about countries and agriculture mean indicators for a number of years, and this data is really ripe to, for example, click on 10 years worth of stuff and insert a sparkline. And then if I drag that down, I get all these sparklines. I was so thrilled when I found this site because coming up with good data for sparklines is pain. This is real. And it's got hundreds of rows in it. It's real information. The data isn't always perfect. So students can analyze this and move it out. They can filter it and do a whole bunch of interesting things with it. So dataworldbank.org is a cool place to go with that. Let's close that up. Data.gov, 15. Data.gov is the government's website for analyzing and visualizing data. So for example, they've got visualizations of, this is gross income and wage information. And you can create views to see this or visualize it and do some filtering. If you don't want it in a donut chart, you can make it a line chart and choose the values you want to view. And when I click on apply, it will reprocess my data in the browser. I didn't install anything to do this. It works in the browser. So data.gov, and your city and your state probably have their own open data websites with information about where you live as well. And this is, again, explore.data.gov.
Can you query a release of technology within a
There are data sets on things like that, yes. A lot of this data comes from the census and medical records, Medicare, things like that. Another thing that's interesting and useful to do with big data is search it. And I want to show you a technology from Google called BigQuery. If I can find it. BigQuery is a technology from Google that allows you to upload your own huge data sets. They charge you for that. Or they have Wikipedia online, and they have a number of other databases online that you can search. So here are some queries that I've been playing with. I said, find me all the 8-letter words in Shakespeare. That didn't work. Let's try it again. Finding all the 8-letter words in Shakespeare. Checked, wherever, disarmed with an apostrophe, mistress. And there's 1,000 of them. How quickly would it take to find that otherwise? Let me go to Wikipedia. How many articles in Wikipedia have the word technology in the title? So here's my query. And Google BigQuery gives you the tools, and I'll show you in a minute, a cookbook that you can use to build some of these queries. In the interest of time, I'm taking these out of the oven today, but there's a cookbook that you can use to try and build some of these. So how many articles in Wikipedia have the word technology in the title? So it's searching through all of Wikipedia in 3 seconds, and it found 90,734 titles about technology. And then I can go and
query Office 2013.
not there yet. But 98,000 articles about Microsoft in general. So the point is that, and then you could download this if you wanted to as a comma-separated values file or as a table and save it. And in this case, I can't save it as a table because it's too big, or save it as a download, but I can save it as a table, and then I can use it in other data sources. Google has another product that I want to show you. So that's BigQuery for searching big data. And if you search for the phrase Google BigQuery, you'll find it. Another one is, has anybody seen Fusion tables in Google? This is an app you can add to Chrome. And it's called Google Fusion Tables. And and what you can do is you can find and search for data on the web that is saved in tables that you can analyze in ways that go beyond spreadsheets. So take a look at this. Let me click on Find Public Data. Oops. And so I'm going to type in, only because I know this one works, Apple stores. And here's a data set with 403 rows about Apple stores in the United States. And for each store, it's got the location name, its latitude and longitude, the address, the number of the store in terms of its rollout, the date that it opened, a picture of the store, and a link to the store's homepage. Here's the database. Well, I can map it. Kind of like that. How hard was that? And when I click on the map, it tells me where it is. Not too bad. I can also create some graphs. So let me add a chart to this data. And what I want to do is see when, I want to try and find a relationship between the dates and the stores that were open on particular dates. So I'm going to go show me the link between the opening date and the store name. And we'll color these just to make it interesting. There's a whole bunch of them, right? But now let's do a filter on this and say, in the opening date, show me stores that opened in 2011. So it shows me the New Haven store, or on September 24th, these 5 stores opened on this particular date. Or these 6 stores opened on this date. These 3 stores opened up on August 27th. So it's a way to filter live data on the web, and you can't do this in Excel easily. So these kinds of tools give us ways to interact with live data and use data in new ways that weren't otherwise possible. Introducing these kinds of tools in our classes gives students an opportunity to sort of see more information about things that they relate with, or create their own data sets by doing a search through BigQuery and Wikipedia, exporting that to a table, and then visualizing like this. Cool stuff. Questions, comments, thoughts before we continue?
It looks like this is a trend that's going to continue to grow. Do you know of any textbooks that have been published on this that we might possibly use in class?
So the question was, it looks like this is a trend that's going to continue to grow. Do I know of any textbooks that tend to include information like this? I'll say mine. I didn't pay you for this. Yeah, actually, one of the things when I updated the Web 2.0 text last year to a CourseMate section, to a CourseMate product, was rather than create an entire book from scratch again, I added one new chapter, or one new mini chapter, one new section to each chapter. And chapter 6, which in the earlier book was about linked data and linking data and cloud computing, in the update is all about 3 things: big data, open data, linked data. And it describes exactly this stuff. And so that's a chapter that is available, whether you purchase it as part of the CourseMate product or individually, but the stuff the content that you're asking for is there.
Is that the Shelley Cashman?
Yeah, it's the Shelley Cashman series product, along with other visualizations and tools for doing linked data and big data as well. Because yeah, big data was really the McKinsey paper that started that terminology about 1.5 years ago now. Was sort of the beginning of the propulsion of this whole idea of big data, or at least that language. And you're right, it's not going away.
How relevant do you think, given the context of big data, is it, from a literacy perspective, people learn about relational databases?
Say that again, please.
How relevant do you think, in the context of big databases, that from the viewpoint of computer literacy courses, that students know about relational databases?
I think it's really important that students know about the question was, how relevant are big data technologies in a world and how versus relational databases? Well, students need to know about relational databases and Access and SQL, because I think those concepts provide the framework for going to this next step where data isn't necessarily rows and columns of tables. I think we still need to start there. And at the same time, I think it's worthwhile to spend a day or a part of a day doing some of the examples like these to say, well, this is what's next. This is where the world is going, at least in the industry. Because again, big data, or the databases that we interact with in our access classes are often consumer or small business kinds of databases, and this will take students to the next level of what's actually happening in the enterprise.
Are you familiar with the Teradata University Network?
I'm not.
University of Arkansas, in conjunction with Walmart, they got a big grant. And Walmart gave them a bunch of data to get started. It's an excellent source to go to if you're interested in this whole area of business intelligence.
Thanks. And say the name of it one more time.
Teradata
Teradata University Network. Thanks.
Teradata University Network.
I should also point out that one aspect of cloud computing that's also up and coming along with software as a service and infrastructure as a service and platform as a service is this whole idea of data as a service. And there are a number of data providers online. The government is one. I showed you Explore Datagov before, and the World Bank site, but also sites like factual.com and datamarket.com that are sort of becoming the YouTubes of data, places where people can go and upload their data for other people to download or use in their own applications. So there are a number of sites like that available these days too. Factual.com and datamarket.com, infochimps.com. All these sites have some for-pay downloadable sites, downloadable data, and a number of free data sets as well. So when I teach Excel, for example, when we do the Sparkline unit, I'll have kids go to the data market, go to the worlddatagov.site that I showed you before, and I'll say, find a data set that's interesting to you. And not only will I ask them to create a Sparkline, I'll say, now look at the trends and understand that Sparkline. What's it telling you? And one of the students in my class came back to me and said, we looked at the rise of AIDS, and then when I was in sociology class, I was able to tell people, we looked at this data in my IT 101 class, and here's what I learned from it. And so it was a way to take the information using the technology concepts they learned here and bring it to their sociology class. I thought that was really cool. I'm sorry?
I think it works well if you partner with a marketing class and management class on the business side. Because it certainly helps them more at understanding what the market is doing in real time.
Sure. Sure, the stock market data is also a source of data with great velocity as well. So we have like about 2 minutes left. Are we done? 0 minutes left. Okay, then then let me just wrap up with 2 closing remarks. The 3 things to remember about big data are the 3 V's, which are volume, variety, and velocity. Lots of websites out there to analyze and use big data. Look at Google BigQuery. Look at Fusion tables from Google as well. Look at some of the sites I've posted in my deck. Go to my website later today, and the slides will be up. They were still warm when I came here, but they will be up later on. This afternoon, if you are looking for something interesting to do, about I don't remember what time it is, 4 o'clock. I think Corinne Hoisington and I are presenting on hot technologies and cool applications, and that's always a treat to do. 4:15. Where? Well, wherever it is, we'll be there, and I hope you'll join us. I hope you learned something new today, and thank you for coming. Happy to stick around. I'm the last thing between you and lunch, so go.